Our next speaker, Zouheir from Tunisia. He's the head of the Department of Geodesy at the Office of Topography and Cadastre in Tunisia. So in that matter, is responsible of the leveling network, is responsible also for the Tunisian GNSS course network, and is also training technicians of the office, and also is teaching geodesy to engineering students to the École supérieure de l'aviation et des technologies in Tunis. So Zouheir.
Yes, thank you, Fernand, for this presentation, and good afternoon, everyone. Thank you for inviting me to this session. So, as Fernand said, I am Director of the Department of Topography and Geodesy at the Tunisian Office of Topography and Cadastre. Today, we'll be presenting data availability efforts in Tunisia and the permanent GNSS station of the Office of Topography and Cadastre in Tunisia. Here's what we will go through in this presentation. I will share my screen. If you can see my screen, Fernand, I'm sharing it.
Yes, we got it.
Yes, do you see that?
But
so
you are seeing everything. Okay, it's okay now. Yes.
Okay, so now in this presentation, the first 3 points, I think that everyone shall hear know what is GNSS, the different GNSS systems today, and GNSS application. We will focus especially at the GNSS used at the Office of Topography and Cadastre, the office in which I work, and the GNSS permanent station and the OTC, our course network, and also the RTK network that we manage here in OTC in Tunisia. So for these 3 points, we can pass very quickly. Everyone knows the importance of GNSS today, and we use it in every aspect of our lives. So also the application, etc. So for the GNSS use at OTC, as you can see that OTC has adopted GPS technology to establish a spatial network since 1998. This network includes points referenced in the terrestrial cartage system, as well as points connected to the IGS network. For this first network, we have 28 points all over Tunisia, from north to south. These points were observed each point 3 days, 72 hours, and computed with cooperation of the National Geographic Institute of France, Institut Géographique National de France, and were tied to the ITRF. I think by that time ITRF 2000, because the processing was after that. So additionally, this network incorporates various order points measured using dual frequency GPS receiver. So for the GNSS continuously operating reference station at OTC, we started back in 2005. We installed 3 course stations in 3 major cities, let's say Tunis, Monastir, and Sfax. And by 2010, an additional 20 permanent GNSS stations were deployed across Tunisia, excluding obviously the Sahara region, bringing the total network to 23 stations. The full system has been operational since 2011, and here we see 2 maps. At 2005, we only have the 3 station installed in Tunis, the capital, the northern part, in the center, Monastir, and in the south, Sfax. These stations were installed back in 2005, and all these other circles you see are projected stations. So in 2010, we get this network. This is the map of Tunisia, and every dot here represents a course station. The course station, as you can see, they cover the major part of the territory, except the Sahara part, this one. So we have 23 stations. And this is a photo of the GNSS permanent station of Tunis on the roof of our main office. This is the antenna, the meteo station, and there is inside there is a tilt matter. So here is a GNSS station architecture, typical architecture of GNSS station at the Office of Topography and Cadastre. We have the receiver. They use it to be connected to a computer, but for now we have an independent receiver. We have a radio modem, and GNSS GSM module. We have also GNSS antenna. They are all shock ring antenna, and a tilt meter to monitor the stability of the building. So the station were installed in compliance with IGS specification. As you know, IGS is responsible for many of the GNSS activities in the world, and they have guidelines on how to install station. We follow these guidelines to install our station. After that, for the processing, we use code final orbits with the Bernays GNSS software, which is well-known software for processing GNSS data, generating various products, including the station coordinates, atmospheric parameters, and more. So this network meets the increasing demand for enhanced interoperability, reliability, and accuracy among users. Okay, for the station placement and site selection criteria, there were many parameters that were taken into account. So first of all, the station were strategically positioned to ensure overlapping coverage within a 700 kilometer radius. The site selection prioritized the following criteria: the security and limited multipath interference, the reliable accessibility, a stable internet connectivity, and power supply. So for these reasons, most of the stations are located at regional OTC offices, while others are installed in public buildings such as the post offices. For the infrastructure, each station is equipped with the following components. As you may see in the picture, a meteorological sensor to record temperature, pressure, and humidity, a tilt sensor to monitor the stability of the structure, a radio link, a GSM link, and a dedicated data link connecting it to the operational center located in Tunis at the main office of the Office of Topography and Cadastre. So all the stations are configured to transmit data every second, operating continuously on a 24/7, 365 basis to the central processing server. The server stores the received data in compressed Linux Hatanaka format. Okay. For the processing of the data, we use the Bernays GNSS software with final code affinities to verify and maintain station coordinates and to check the quality, of course, of this station. And another point is that our network operates as a dedicated NRTK, Network Real-Time Kinematic Service. This data is also utilized by the network management software to compute real-time correction for authorized users, which are subsequently transmitted in real-time. And rigorous quality control procedures are implemented to ensure the integrity and the reliability of the network data. So the OTC provides comprehensive information to users, including network status updates, data availability, conversion utilities, and quality control reports. When we speak about data availability and data sharing and contribution to international United Nations initiatives like ArabRef and AFF, as you may know, Tunisia is a member of both UNGGIM Arab States and UNGGIM Africa. The data for 3 core stations have been uploaded to the ArabRef platform hosted by the Kingdom of Saudi Arabia, KSA, and we have data since 2005 for the 3 stations that were chosen. These 3 stations are the oldest ones: Tunis, Monastir, and Sfax. As I said at the beginning, this data is uploaded to the Kingdom of Saudi Arabia platform. And we hope that the same contribution can be extended to the AFREF project to actively support its realization. So since Tunisia, another point is that since Tunisia national reference system uses a terrestrial reference frame, it's the ellipse with Clark 1880 EGN, transformation parameters have been computed to enable bidirectional conversion between spatial and terrestrial coordinate systems. Okay. In OTC, we use both single RTK mode and for now, network RTK mode. Here are different presentations speaking about the advantage of each technique, the tradition versus, excuse me, I'm going fast because everyone, I suppose that you all know the difference between traditional RTK and the network RTK, so this is for your information. As I said, we store data in the RINEX format. Also, this is an extract from a file describing this very famous format used by all geodesists all over the world to process transfer data. These are some other tools we use to quality control our data, except that TXC is no longer supported, but still there. We use other tools like GFZ RMX. This is a standard processing sequence using the Bernese GNSS software that we are using here to compute our data. So this is for the excuse me, I go so quickly to the conclusion. So the use of GNSS techniques offer many advantages, as you may know, in productivity, precision, coherence. The OTC has good experience in installing and managing and using coarse networks. It also has extensive technical knowledge to ensure the transition between terrestrial and spatial systems. And also, OTC is trying to be more collaborating or helping to the realization of the ARABREF and AFREF via sharing data and technical knowledge or expertise. Thank you for your kind attention. I think I'll go very quickly. Thank you for your attention.
Thank you very much, Zouheir. Thank you for having an eye on the time.
Yes.
And thank you for all the efforts for bringing AFREF and ALABREF on both. Thank you very much.
Thank you. Thank you. Thank you very much.
And dear colleagues, do you have any comment or question for Zouheir before we move to the next speaker?
There are a lot of sorry. There are a lot of questions in the chat. Most of them revolve around accessibility of the data. Is there real-time data available to the public? Someone also asked about hourly RINEX data. Someone else asked about a live site showing the map of stations. Can you comment on this, Zouheir?
Yes, thank you, Marty. So for the question for the data availabilities, they are only for now. We are going to make them available online and the dedicated website for the network. But for now, they are only demanded or used by private sector, and they can only get the data from our office. They reach to us, and we prepare there is RINEX data of 1 second and 1 hour, hourly data, 1 day, etc. All the frequencies, we have 1 second data. For the accessibility of the data, for now, it is not free for the post-processing. Also, for the real time, they have to pay a little amount to get the RTK correction. So that's quickly what we have here for now.
Very well. So available upon request and use through a small fee. But people should contact you directly, or do you have an address that people can contact for this type of access?
Yes, we have the website of the office. Maybe I will put it in the chat so that everyone could reach to the OTC. right now. I will write it on the chat.
Okay.
So yes, I write it in the chat so you can see the web address of our office where they can get all the contacts they need to inquire about data and RTK network.
Very well. Another question, thank you very much for this. Another question was, which ITRF is Tunisia using for their course network?
For our network, RTK network, we are using the ITRF 2000 because when we first computed the 28 special reference network points, they were tied to the ITRF 2000. And as you know, this network, this course network, RTK network, is used for land registration and cadastral surveying. So we do not, we have not the choice to change the coordinates. We must keep the coordinates in that reference frame. But internally here, we use Bernese and we compute in all the different other reference frames the data. But the coordinates which are fixed on the RTK network are just for the cadastral surveying and land registration purposes. They should not be changed.
Interesting. Thank you very much. Another question that might relate to it, since we are close to time, is from Bruno again. Asking about the ocean loading model you might use in your GNSS computation and whether or not you are using different and testing different ocean loading models because of the location of Tunisia.
No, for the location of Tunisia, we are using only one, the model that comes with the Bernese GNSS software, just one model, and that's it. We are not testing different models. Maybe it's interesting to do this. We can exchange more about this subject, and we test a different model to see the results and the difference.
Okay, thank you very much. I will keep track of the other questions. I know that we have people raising their hand also. I will keep track of this and maybe we can bring that back during the discussion.
Okay, you are welcome. Thank you.
Thank you very much.